There is a place at the center of our galaxy that should not be allowed to exist, not by any poetic measure, not by any dramatic license borrowed from science fiction, but by the strict, cold, merciless language of physics, the kind of physics that gets written into textbooks, defended in dissertations, and cited by people who have spent decades teaching the universe how to behave. This place, located approximately 26,000 light-years from the patch of unremarkable rock and ocean you currently call home, violates expectations so completely, so quietly, and so persistently that the scientists who discovered its strangest inhabitants still argue about what those inhabitants actually are. And the most unsettling part of all of this is not the place itself. It is the objects that live there. 6 of them, as far as we know. 6 objects that were spotted over the course of years of meticulous, painstaking observation with some of the most sophisticated instruments humanity has ever assembled. 6 objects that were cataloged, measured, tracked, mapped across the sky, assigned names so clinical and precise that they tell you almost nothing about what you are actually looking at. We called them G1, G2, G3, G4, G5, and G6. The G stands for a category of object, a classification, a scientific drawer into which something was placed so that the mind could organize it, file it, and move on. But the universe, it turns out, has very little respect for our filing systems. When astronomers first began studying the region at the center of the Milky Way with the Keck telescope, and later with the Very Large Telescope in Chile, they were looking for something they already understood. They were mapping the orbits of stars near what they knew to be a supermassive black hole. They had their models, they had their equations, they had their expectations. And for years the data behaved. Stars moved the way stars were supposed to move. Orbits curved the way orbits were supposed to curve. The universe was cooperating. Then something in the data did not cooperate. Something appeared on the infrared sensors that was elongated, diffuse, and extended. The kind of signature you get from a cloud of gas and dust, not from a star. It scattered light in the way that particles of gas scatter light. It had the spectral signature of ionized hydrogen, of excited matter being heated from the outside in. Every instrument pointed in its direction said the same thing. This is a cloud. This is a collection of gas and dust. This is the kind of diffuse structure that a gravitational field slowly pulls apart over millions of years. Except that clouds do not hold themselves together. Not like this. Not near a black hole with the gravitational appetite of 4 million suns. Not in a region so violent, so radiatively intense, so shredded by tidal forces that any ordinary cloud of gas would have been torn to streamers long before anyone had a chance to name it. And yet there it was, compact, coherent, moving fast, moving with a velocity that no cloud of gas has any right to maintain. Moving along an orbital path so tight, so precise, so stubbornly resistant to the kind of disruption that should have scattered its constituent molecules across millions of kilometers of empty space, that the word cloud started to feel like a category error, like calling a hurricane a breeze because both involve moving air. Technically accurate in a way that is functionally useless and perhaps dangerously misleading. That first object was G2, and what happened to G2 in the year 2014 will constitute one of the strangest, most consequential, most philosophically provocative events in the history of modern astrophysics. Not because of what happened to it, but because of what did not. Before we get there, we need to understand where this is happening. We need to understand the stage, because the stage is not incidental to the drama. The stage is the drama. And until you feel, in your body, in the part of your brain that evolved to understand danger at human scale, until you feel what the galactic center actually is, you cannot begin to appreciate what it means for anything to survive there. Imagine the galaxy as a disk. a flat, rotating spiral structure approximately 100,000 light-years across, containing somewhere between 200 billion and 400 billion stars, plus the gas, dust, dark matter, and gravitational machinery required to hold all of that together. Now imagine standing at the outer edge of one of the spiral arms, looking inward. That is approximately where you are. That is where the Sun sits, embedded in the Orion arm, orbiting the center of the galaxy at a speed of roughly 220 kilometers per second, completing one full orbit every 225 million years. The last time the Sun was in this exact position in its orbit, the dominant life forms on Earth were early dinosaurs. That is the timescale on which the galaxy operates. That is the speed at which you are currently moving right now without feeling it, because there is nothing near enough to give you a reference point. Now travel inward, compress the distances, move from the comfortable, relatively quiet outer disk toward the turbulent, dense, radiation-soaked center. As you travel, the density of stars increases, the frequency of supernovae increases. The intensity of magnetic fields increases. Everything becomes more extreme. Everything becomes more violent. Everything becomes compressed into a smaller and smaller volume of space, like a city growing denser toward its downtown core. Except the downtown core in this analogy is surrounded by an accretion disk of superheated plasma and anchored by a gravitational singularity that does not particularly care about urban planning ordinances. At the very center, at the point around which everything ultimately rotates, sits Sagittarius A star. Say that name slowly. Let it register. Sagittarius A star. It is a supermassive black hole. It has been accumulating mass for longer than the Earth has existed. Its mass is currently estimated at approximately 4 million times the mass of the Sun. 4 million suns collapsed into a region of space smaller than the distance between the Earth and the Sun. The event horizon, the point of no return, the boundary beyond which not even light escapes, is roughly 17 million kilometers in radius. That sounds large until you realize that the gap between the Earth and the Sun is about 150 million kilometers. Sagittarius A star event horizon is not much larger than the orbit of Mercury. It is, in astronomical terms, extraordinarily compact for something containing the equivalent of 4 million stellar masses, and around this thing, in orbits that take years rather than millions of years to complete, move the G objects. To appreciate what that means, consider the following. The G objects orbit Sagittarius A star at distances ranging from roughly a few hundred to a few thousand astronomical units at their closest approach. This might sound like a comfortable distance until you remember that the object at the center of those orbits is not the Sun. It is 4 million suns worth of gravity concentrated into a point. The tidal forces at those distances, the difference in gravitational pull between the near side of an object and its far side, are sufficient to rip apart gas clouds, disrupt star-forming regions, and in principle, destroy almost anything that does not have an extraordinary internal cohesion. This is the neighborhood. This is the housing market. 6 objects exist in this neighborhood, and they have been there long enough for us to map their orbits and watch their behavior. And their behavior is impossible. That word has specific meaning here. Not impossible in the casual sense of extremely surprising. Not impossible in the journalistic sense of something unexpected that generates clicks. Impossible in the strict sense that the models which describe how matter behaves under these conditions, models tested and refined and cross-checked against observations for decades, those models predict that objects like the G objects should not be able to do what the G objects do. They should not be able to maintain their coherence. They should not be able to hold themselves together against the tidal forces they encounter. They should not be able to look like gas clouds and orbit like stars simultaneously, for years, without one or the other characteristic dissolving into the other. But they do. And the most dramatic proof of that impossibility occurred in the autumn of 2014, when G2 reached periapsis, the closest point in its orbit to Sagittarius A star, and the entire astronomical community held its breath. The prediction was clear. The math was unambiguous. The models were in agreement. G2 was going to be destroyed. When astronomers first tracked G2 orbital path and projected where it was heading, the consensus formed quickly and with considerable confidence. Here was an object displaying all the characteristics of a compact gas cloud. Here was a gas cloud on an orbital trajectory that would bring it closer to a supermassive black hole than anything we had ever watched before in real time. And here was a set of well-established equations describing what happens to gas clouds when they venture too close to extremely massive gravitational sources. The answer those equations gave was unambiguous. The tidal forces would stretch the cloud. The differential gravity would elongate it into a thin, glowing streamer of superheated gas. The material would spiral inward, and G2, as a coherent object, would cease to exist. Telescopes around the world were positioned to capture this event. Observation time on the world's most powerful instruments was allocated. Papers were prepared in advance, waiting only for the data that would confirm the predicted destruction. Scientists who had studied Sagittarius A star for their entire careers arranged to be available during the periapsis passage. This was going to be a landmark event. This was going to be one of those moments where the universe performed exactly as calculated, where theory and observation aligned in a satisfying, beautiful, completely expected way. G2 reached periapsis. G2 was not destroyed. It was not stretched into a streamer. It was not shredded. It was not dispersed. It was not tidally disrupted in the manner that the models had described with such confidence. G2 passed through the point of closest approach to one of the most gravitationally extreme objects in the entire galaxy, at distances that should have been lethal by any definition of the word, and it emerged from that encounter as a recognizable, coherent object. Not only did it survive the approach, which alone was sufficient to cause a significant reassessment of what kind of object G2 could possibly be, but in the months and years following the periapsis passage, astronomers observed something that deepened the mystery considerably. G2, which had shown some degree of stretching and elongation during the closest approach, appeared to recompact. It appeared to pull itself back together. The extended, distorted shape that developed during periapsis gradually recovered towards something resembling its pre-periapsis form. The object that had been stressed and strained by forces sufficient to shred ordinary gas clouds reassembled itself into a coherent structure. Gas clouds do not do this. Gas clouds that get close to supermassive black holes do not pass through the encounter and then organize themselves back into compact structures on the other side. Something is holding G2 together from the inside. Something inside G2 is providing a structural integrity that no ordinary cloud of gas and dust possesses, and that something is almost certainly a star. But here's the problem with that explanation. If there is a star inside G2, where is it? Stars are bright. Stars emit light across a broad spectrum. The infrared emissions from a star embedded in a gas cloud should be detectable. The spectral signatures should be present in the data. And when astronomers looked for those signatures, looked for the point source brightness that would indicate a stellar core inside G2 diffuse outer envelope, they did not find the clear, unambiguous signal they were looking for. The star, if it exists, is hidden. It is hidden by the very cloud that surrounds it. shrouded in layers of gas and dust that absorb and scatter the light the stellar core is producing, presenting to the telescope not a star but a cloud, not a hard bright point, but a soft, diffuse glow. The star is there. The survival of periapsis essentially demands it, but it is invisible in the way that matters most, invisible to instruments that cannot penetrate the veil. And this is where the story becomes truly extraordinary, because G2 is not alone. It is one of 6, and when the orbits of all 6 G objects are mapped and examined together, a pattern emerges that is either deeply meaningful or a coincidence of staggering improbability. All 6 objects occupy orbits that are broadly consistent with each other in terms of orbital plane and angular momentum. All 6 objects display the same fundamental paradox: the diffuse appearance of a gas cloud combined with the orbital behavior and structural resilience of a stellar object. All 6 have survived in one of the most gravitationally violent environments in the galaxy. And all 6 present the same tantalizing near invisibility of whatever is holding them together from within. 6 impossible objects dancing in tight orbits around 4 million solar masses of compressed gravity. 6 objects that broke the model. 6 objects that forced a reassessment. 6 objects that looked the physicists in the eye and said, "You do not know what we are." The simplest, most conservative explanation for the G objects is that they are young stars recently formed from the dense gas that permeates the galactic center, still embedded in their natal cocoons of gas and dust. This would explain the extended cloud-like appearance. It would explain the survival of periapsis if the stellar core is compact and massive enough to resist tidal disruption. It would be a relatively comfortable explanation, fitting broadly within existing models of stellar formation and evolution, requiring no fundamental revision of physics. But there are problems with this explanation. The region immediately surrounding Sagittarius A star is exceptionally hostile to star formation. The conventional wisdom in astrophysics, derived from decades of theoretical work and observational evidence, is that the tidal forces near the central black hole should prevent gas from collapsing gravitationally into stars. The tidal acceleration, the force that tries to pull infalling material apart rather than letting it coalesce, should win over the self-gravity of any gas cloud attempting to condense into a protostellar core. This means that the inner parsec of the galactic center should, by standard models, be a region where new stars cannot form regardless of how much gas is available. And yet there are young stars there, many of them. The galactic center harbors young stars that should not exist under the conventional star formation paradigm. This mystery, sometimes called the paradox of youth, was already a recognized challenge to standard models long before the G objects came along to complicate things further. The G objects do not stand alone as anomalies. They inhabit a region that is already, from the perspective of stellar astrophysics, deeply puzzling. But the G objects add a new layer to that puzzle. They occupy a middle space between star and cloud that implies a history more complicated than simple formation in place. And this brings us to the hypothesis that has gained the most traction in recent years, the one that strikes most people who hear it as being equal parts elegant and improbable. The kind of explanation that makes you stop and think, how did the universe come up with that? The G objects, according to this hypothesis, are the products of stellar mergers. More specifically, they are the remnants of binary star systems, systems in which 2 stars orbit each other, that were dragged by gravitational interactions toward the center of the galaxy and eventually forced into collision. When 2 stars in a binary system merge, the result is not simply a larger star. The merger is violent. It is energetic. It releases enormous quantities of material that forms an extended envelope around the newly merged stellar core. The merged object sits at the center, dense and compact, a stellar remnant with the mass of the two original stars combined. Surrounding it, like a vast, diffuse cocoon, is the expelled material from the merger event: gas, dust, partially ionized matter, the shredded outer layers of two stars that no longer exist as separate entities. The appearance of such an object would be, you may already see where this is going, exactly what we observe in the G objects. Extended and diffuse on the outside, presenting an infrared signature consistent with a cloud of gas and dust. Compact and stellar on the inside, with a dense core capable of surviving gravitational encounters that would tear apart any pure gas cloud. The analogy that has been used to describe this structure is that of a hard-boiled egg wrapped in cotton wool. The cotton wool scatters light, diffuses the appearance, makes the outside look soft and unstructured. The hard-boiled egg inside provides the mechanical resistance, the structural integrity, the thing that refuses to break no matter how hard the universe squeezes. The whole structure moves through space at stellar velocities, following an orbital path defined by the gravitational dynamics of the galactic center, looking from the outside like a gas cloud, but behaving, in every mechanically meaningful way, like a star. This explanation is powerful because it solves multiple problems simultaneously. It explains why the G objects look like gas clouds, because they are surrounded by gas ejected during the stellar merger. It explains why they behave like stars, because they have stellar cores. It explains why they survived periapsis, because the stellar core retains the gravitational self-binding energy required to resist tidal disruption. It even offers a mechanism for the self-reassembly observed after G2 closest approach. The stellar core acted as a gravitational anchor, drawing the disturbed outer envelope back toward it after the peak tidal stress of the encounter had passed. And it fits within the broader context of what we know about the galactic center. The extreme stellar density of the inner parsec means that binary systems are common there, and the complex gravitational dynamics of that region provide abundant mechanisms for driving binary systems onto trajectories that bring their component stars into close contact. The galactic center is, in a sense, a cosmic pressure cooker that forces stars together, strips them of comfortable distances, and occasionally demands that two separate objects become one. The G objects may be the survivors of that process. They may be, in a very real sense, scars, evidence of violent collisions that happened in the deep past, possibly hundreds of thousands of years ago, now slowly fading as the merger ejecta continues to expand and thin and eventually disperse, gradually revealing the dense stellar remnant at the center. In another million years perhaps, what we currently see as a diffuse gas cloud will have thinned enough that only the star remains. The cotton wool will be gone, the egg will be visible, but this is not the only hypothesis. And it would be intellectually dishonest to present one explanation, however elegant, as though the debate were settled. There is the more conservative interpretation that the G objects are not merger products at all, but simply very young, massive protostars still in the process of contracting from the diffuse clouds that gave them birth. Under this scenario, the gas envelope is not merger ejecta, but natal material, the raw stuff of star formation that has not yet fully accreted onto the growing stellar core. This explanation is tidy. It does not require exotic mechanisms. It fits within existing star formation theory, even if it strains some of the boundaries of that theory given the hostile environment. Then there are the more radical possibilities, the ones that live at the edge of respectable speculation, the ones that researchers mention carefully, qualified with appropriate epistemic caution, but mention nonetheless because the data sometimes demands it. Could the G objects be something entirely new? a category of astronomical object that does not yet exist in the current taxonomy. The history of astronomy is full of objects discovered before anyone had a theory to explain them. Pulsars were initially so bizarre that their discoverers briefly considered the possibility that they were artificial signals. Quasars were so luminous and so energetically extreme that their nature was debated for years before the mechanism became clear. Fast radio bursts, millisecond duration pulses of radio energy from cosmological distances, are still not fully understood. The universe has a consistent record of producing things that our models were not prepared for. Could the combination of extreme gravity, extreme stellar density, extreme radiation fields, and extreme gas dynamics near Sagittarius A star produce objects with properties that simply cannot arise anywhere else? Objects whose physics is genuinely novel. Objects that require not a refinement of existing theory, but a genuinely new category of understanding. We do not know, and that uncertainty is not a failure of science. It is science working exactly as it is supposed to work, confronted with data that exceeds the current explanatory framework and responding with the only honest answer available. We do not yet know, but we are working on it. And working on it requires sitting with the discomfort of not knowing. It requires resisting the temptation to force new phenomena into old categories simply because old categories are familiar. The G objects do not care whether we have a satisfying explanation for them. They will continue to orbit and survive regardless of whether our theoretical frameworks accommodate their existence. Pause here, step back. Not from the science, but from the urgency that the science sometimes generates. The urgency to explain, to classify, to place things in drawers. Step back far enough to see not just what the G objects are, but what they suggest about the broader nature of the thing you are living inside. The G object suggests this. The universe contains structures that survive situations that should destroy them. That statement might seem obvious, even banal. Of course, the universe contains structures that survive. Planets survive supernova shockwaves. Stars survive close encounters with other stars. Galaxies survive collisions with other galaxies, merging over billions of years into new configurations that retain the memory of what they were before. But the G objects are different. And the difference is hard to articulate without reaching for something that sounds like metaphor, but is actually, if you follow it carefully, quite precise. The G objects survive not by being strong, not by being massive or dense or enclosed in some protective shielding. They survive, if the binary merger hypothesis is correct, by being the product of a catastrophe. They exist as coherent objects because two things that were separate were destroyed as separate things and became, through that destruction, a new thing. A thing that is more gravitationally integrated than either of the original components. A thing that would not exist at all if the violence that created it had not occurred. Think about what that means. In the most violent, most gravitationally extreme, most radiatively hostile environment in the entire Milky Way galaxy, nature produces objects specifically suited to survive in that environment, and produces them through a process of collision and merger that is itself driven by the violence of that environment. The danger creates the survivor. The destruction creates the object capable of surviving destruction. The thing that should not be able to exist there does not exist there despite the conditions. It exists there because of the conditions. This is a pattern that shows up, if you look for it, at every scale the universe offers. At the molecular scale, the extreme conditions of early stellar nucleosynthesis produce elements heavier than hydrogen and helium, elements that require the violence of stellar cores and supernova explosions to assemble. And those elements become the raw material for planets and chemistry and life. At the stellar scale, the death of massive stars in supernova explosions distributes those heavy elements across the galaxy, seeds new star-forming regions, triggers the formation of new stellar generations, destruction as construction, catastrophe as creation, the violent process that should end things instead beginning them. We are part of this pattern. Every atom in your body heavier than hydrogen was forged in the nuclear furnace of a star that has since exploded. You are made of stellar catastrophe. You carry, in the very chemistry of your cells, the record of a universe that knows how to make structure out of chaos, and does so repeatedly, at every scale, in every environment, including the environments that look the most thoroughly hostile to structure of any kind. The G objects at the galactic center are, from this perspective, not merely interesting scientific data. They are a demonstration performed at a scale and in an environment that was not designed for human comprehension, but which arrives at a conclusion that resonates with something deeper than intellect. Even at the edge of the abyss, something holds together. Not because the universe is benevolent, not because physics contains a special provision for the preservation of interesting structures, not because there is any guarantee, any cosmic insurance policy, any law written into the nature of space and time that says coherent objects shall persist. The G objects hold together because the conditions that tried to destroy them were also the conditions that, by indirect and elaborate mechanism, provided them with the internal architecture required to resist destruction. The violence and the resilience are not opposed. They are the same process, viewed from different points in time. We found these objects because we looked, not because we expected them, not because theory predicted their existence in advance. We found them because we pointed our best instruments at the sky and watched carefully and for a long time and with enough patience to recognize that what we were seeing did not fit the existing categories. That act, the act of looking without a predetermined conclusion, the act of accepting data that refuses to behave, is perhaps the most remarkable thing about the story of the G objects. Because the objects are simply doing what objects do. They are following the laws of physics, even if we have not yet fully understood which laws apply to them. They have no investment in being mysterious. They simply exist in the way that everything in the universe simply exists, without apology and without explanation. It is we who look. It is we who ask why. It is we who feel the particular kind of vertigo that comes from learning that something you thought you understood does not work the way you thought, and that the something which broke your model is located 26,000 light-years away and weighs 4 million suns and is surrounded by 6 dancing objects that should not be there, orbiting in patterns that should not be possible, having survived encounters that should have destroyed them. That vertigo is not a failure of knowledge. It is the sensation of knowledge expanding. It is the feeling of a model breaking and a larger model beginning to form in its place, the way a seed must break before it can become a tree. It is uncomfortable, in the way that growth is always uncomfortable. But it is the right feeling to have when standing at the edge of what is known, looking into the larger space of what is not yet known. The G objects are at the edge of a gravitational abyss, orbiting the darkness at the center of the galaxy, dancing in defiance of the forces that should have erased them. And we are here, 26,000 light-years away, looking up and watching and trying to understand. Two kinds of things that should not, by any ordinary measure, exist in their current form. Two products of processes violent enough to destroy, complicated enough to create, and vast enough to make any final accounting feel permanently premature. The universe is not obligated to make sense to us. It is not obligated to arrange its phenomena into patterns that fit within the cognitive architecture of the primate brains we brought to the task of understanding it. It is not obligated to stay within the boundaries of the models we build for it, or to respect the classifications we assign to its contents. or to behave in the way our equations predict when something truly novel appears in our data. The galactic center, that dense, violent, improbable crucible of stellar mergers and young stars and impossible hybrid objects, has been operating without reference to our models for 12 billion years and will continue operating without reference to our models for billions more. What we can do, what we have done, and what we will continue to do is look. Look more carefully. Look with better instruments. Look with more patience. Look with the willingness to let the data break the model, because a broken model is not a defeat. It is an invitation to build a better one, an invitation to expand the scope of what we believe the universe is capable of, and to sit with the discomfort of not knowing while the better model slowly takes shape. The 6 impossible dancers at the center of the Milky Way are still out there, still orbiting, still surviving, still refusing to be only one thing, still holding their centers together against forces that would prefer them scattered. They have been doing this since long before anyone was looking. They will be doing this long after the last telescope falls silent. And that perhaps is the most honest thing the universe has ever told us. Not through language, not through any message directed at creatures capable of receiving it, but simply by existing in the way it exists, doing what it does, being what it is. It does not need us to understand it in order to be extraordinary. It was extraordinary before we arrived. It will be extraordinary long after we are gone. And in the narrow window of time when something on this planet looks up and asks what is out there and why, the G objects continue their impossible dance, holding together at the edge of everything, showing us something that no equation has yet fully described and no model has yet fully contained. That something holds together, even here, even now, even at the very edge of the abyss.